Hey guys, today we're going to look at how to solve square root equations as well as cube root equations. Now, what we have here is we have these two equations accompanied with their graphs. So let's look at this first one. We have 4 over 3, the square root of x plus 1 is equal to 3. Now, the left side of the graph of the equation here is this red part of the graph. We have the 4 over 3 square root of x plus 1. This means that the radical function was shifted to the left one, and there is a vertical stretch of 4 over 3. So you can see how it was shifted to the left, and there is a stretch. Now the right side of the equation, which is equals to 3, that's the blue line here. It is a horizontal line because if it equals 3, that means that the y is equal to 3, since equations are usually f of x equals 3. So this would be your f of x, which we know is y, and equals 3. So that's the horizontal line. In terms of solutions, when you're looking at a solution, you're looking for when the two graphs are going to intersect. And your answer would be, like if I were to solve this equation, we would be solving for x. So the solution would be the x value where there is the point of intersection. So here we see the red and the blue, they intersect here, which is at x equals 4. So this would be the solution of that equation. Now if I look at this one, we have here the square root of 3 over 2x is equal to 1/2 x. So again, the left side of this equation, the square root of 3 over 2x, that's the red, that's my radical. And then 1/2 x is a line, so that's the blue line here. Now in this one, we actually have 2 points of intersection. We have here at x is equal to 0, and here at x is equal to 6. So these are my two solutions. So as you can see, we can either have one solution or two solutions. There is also a possibility, even though it's not shown here, of having no solution. And no solution would be, let's say, if you have your square root graph, and then you have a line that does not intersect with that radical. This would indicate that the equation has no solution, since your solutions are always going to represent where your graph would intersect with the line. Now let's have a look at how we would solve these equations algebraically. Now a radical equation is basically any equation that either has a radical or it's raised to a rational exponent, since we learned that rational exponents do represent radicals. Particularly to square root equations, because when you square root a number, you end up with plus or minus, that means that when you square a radical equation, you're going to sometimes get two solutions. And if you get two solutions, then that means you're going to have to check them. Because if you check them and one of them does not satisfy the equation, then that is called an extraneous solution, which means that it is not an actual solution for the equation. So let's have a look at what that would look like. For this equation, we have 2 plus the square root of x plus 10 is equal to x. So I have steps here that we can follow for when we're solving this kind of equation. Your first step is to isolate the radical, meaning we want to get this square root all by itself. Since I have this 2 over here, I want to get rid of that 2. Since it's positive, I'm going to subtract 2 to both sides. So we have now the square root of x plus 10 is equal to x minus 2. Once we have isolated the radical, then our next step would be to square both sides. So we did step 1, now we're going to do step 2. So we're going to square. This essentially is going to cancel out the square root. So now what we have is x plus 10 is equal to x minus 2 squared. Now x minus 2, remember that this is x minus 2 times x minus 2. So we're going to need to FOIL, or distribute everything. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is another negative 2x. And negative 2 times negative 2 is a positive 4. Now let's simplify this. So we got x plus 10 is equal to x squared minus 4x plus 4. Because when I look at my equation, I see that my highest exponent of 2, that means that this is a quadratic equation. In order to solve this quadratic, the simplest way would be to make the equation here equal to 0, either by moving all of your terms to the left or all of the terms to the right. I like to keep my x squared positive, so I'm going to move these two terms over to the right side. And I'm going to do that by subtracting this x over and subtracting it here and subtracting this 10. So now I have nothing left on this side. And that means that the equation is going to equal to 0. So let's write this out. I have the x squared. Negative 4x minus x is negative 5x. And positive 4 minus 10 is negative 6. Equals to nothing left, so 0. So I have simplified. Now that it equals to 0, my next step is to factor. And by factoring, what I mean is we're going to open our two parentheses. We're going to see what two numbers multiply to give us negative 6 and add to give you negative 5. So we got x here on both sides. The two numbers that multiply to give me negative 6 and add to give negative 5 are negative 6 and positive 1. Negative 6 times 1 is negative 6, and negative 6 plus 1 is negative 5. And this equals to 0. So we are done factoring. Now we're going to use the zero product property. And what that means is that you take each of these individual factors and make it equal to 0. Now the reason we do that is because if we make this factor equal to 0, 0 times whatever is in here is still going to equal to 0. And the same thing for this factor. If I make this equal to 0, it doesn't matter what's here, 0 times anything would equal to 0, making the equation true. So what I get is that x is equal to 6, as well as x is equal to negative 1. Since here I'd have to add the 6, and here I'd have to subtract the 1, so those are my two x values. So essentially, these would be my solutions. And we got that by using the zero product property. But the final step is to check for any extraneous solutions. Now how we do that is we take our x values and we're going to plug it in to the original equation. So let's start when x equals 6. I'm going to plug it in here. 2 plus the square root of 6 plus 10 is equal to 6. So I plugged x is equal to 6 into every x. We got here 2 plus the square root of 16 is equal to 6. 2 plus square root of 16 is 4 equals 6. 2 plus 4 does indeed equal 6, so this is true. So this is a solution. Now let's try when x equals negative 1. I'm going to plug it in here to my equation. So 2 plus the square root of negative 1 plus 10 is equal to negative 1. Now when I work that out, I get 2 plus the square root of 9 is equal to negative 1. The square root of 9 is 3. But 2 plus 3 does not equal to negative 1. So this is what I mean by an extraneous solution. Negative 1, when I plug it into my original equation, does not make that equation true. So this is extraneous. So my only solution is going to be x is equal to 6. Let's try a couple more. I have here x plus 5 raised to the 1/2 minus 2 is equal to 1. Now this is, even though it's raised to a rational exponent, if you prefer, you can always rewrite that as the square root. since remember, the exponent of 1/2 represents the square root. So the square root of x plus 5 minus 2 equals 1. I'm going to add the 2, and I get the square root of x plus 5 is equal to 3. Next, we're going to square both sides. So the square root is going to cancel with this exponent, and I get x plus 5 is equal to 3 squared, which is 9. Here I didn't have to FOIL like I did in this previous example, because here we had, instead of just a number that was being squared, I had x minus 2, a binomial that was being squared. Next, I would subtract the 5 to finish solving for x, and I get that x is equal to 4. Now before I can confidently say that this is my answer, I'm going to plug it back into my original equation and make sure that it equals. So we have the square root of 4 plus 5 minus 2 is equal to 1. The square root of 4 plus 5, that's the square root of 9, and the square root of 9 is 3. And 3 minus 2 does equal to 1, so therefore this is indeed a solution. For our last one here, we have x plus 6 raised to the 1/2 minus 2x minus 4 also raised to the 1/2 is equal to 0. I'm going to rewrite this with the radicals. So this is the square root of x plus 6 minus the square root of 2x minus 4 equals 0. Now in this case, our first step is always to isolate the radical, but I have 2. So if that's ever the case, you want to get one radical on one side and the other radical on the other side. So that way, when you square, the radicals will cancel. So I'm going to add the square root of 2x plus 4 over to the other side. So I get the square root of x plus 6 is equal to the square root of 2x plus 4. Like this, when I square both sides, both of those radicals are going to cancel. So this cancels with this, and I get x plus 6 is equal to, and over here, same thing, the radical cancels with the exponent, so it equals to 2x plus 4. Now I can solve for x. Now in the other one, in the previous slide, I made everything equal to 0 because it was quadratic. But in both of these examples, you see that we do not have an exponent of 2. So I don't need to make it equal to 0 and factor. Instead, I am going to isolate the x variable. So I'm going to subtract this 2x just because I like my x's to be on the left side. And then I'm going to subtract this 6 so I have all of my numbers on the right side. So on this side, I'm left with negative x is equal to 4 minus, oh, this is supposed to be a minus 4. Just realized my mistake. I wrote it wrong. This is 2x minus 4 minus 4 minus 4. So negative 4 minus 6 is negative 10. Now I'm going to divide by negative 1 to cancel out that negative, and I get that x is equal to 10. Just like in this example, even though I only have one solution, I'm going to go ahead and plug it into the original equation to make sure that they are indeed equal. So the square root of 10 plus 6 minus the square root of 2 times 10 minus 4 equals 0. The square root of 10 plus 6 is the square root of 16 minus 2 times 10 is 20 minus 4 is also 16. And I get the square root of 16 minus the square root of 16 is equal to 0, which is indeed true. So this is a solution. If you ended up that the square roots were not equal, then that would have meant that when you subtracted, it would not equal to 0 and there would be no solution. Now, let's have a look at cube root equations. A cube root equation is just like a square root equation, except instead of square root, it's now cube root. So we're still going to start off an equation like this in the same way that we start off square root equations, which is to isolate that radical. So I'm going to subtract the 7 here to get that radical by itself. So I get the cube root of x plus 2 is equal to negative 2. Instead of squaring both sides, because this is not a square root equation, I'm always going to apply the apply the exponent that matches the index of the radical. So that way that radical will cancel. Since the index of a cube root is 3, that means that I am going to cube both sides of the equation. That way the radical cancels with the exponent, and I'm left with x plus 2 is equal to, now negative 2 cubed is negative 2 times itself 3 times, which negative 2 times negative 2 is 4, times a third negative 2 is negative 8. And then now I subtract the 2, and I get that x equals negative 10. Now I don't have to check here for extraneous solutions. I only check for extraneous solutions with even roots, like the square root or fourth root, etc. But odd roots, whenever you cube root or fifth root or seventh root a number, it's always one number, not two, like when you square root. So you don't have that issue of having extraneous solutions. So bottom line, if you have an even root that you're solving for, you check for extraneous solutions. But when you have an odd root equation, you don't have to check for extraneous solutions. Let's try a couple more examples of cube root equations. Here I have 2 times x minus 50 raised to the 1/3 is equal to negative 10. I'm going to rewrite this with the radical. Only the x minus 50 has that exponent, so this 2 is on the outside, and it's the cube root of x minus 50 is equal to negative 10. I want to isolate this radical, so I'm going to divide the 2 to both sides. So I got the cube root of x minus 50 is equal to negative 5. Next, I'm going to cube both sides of my equation. This radical will cancel with the exponent, and I'm left with x minus 50 is equal to negative 5 cubed, which is negative 5 times negative 5, which is positive 25, times the third negative 5 is going to be negative 125. Finally, to solve for x, I would add the 50. So x is going to equal to negative 125 plus 50, which is negative 75. And again, I don't have to check for extraneous solutions since this is a cube root equation. For my last one, I have the cube root of x minus 5 minus 1 is equal to x. Again, I want to isolate this radical. So I'm going to add 1 to both sides. So I have the cube root of x minus 5 is equal to x plus 1. Next, I'm going to cube both sides. Remember that we're always cubing everything on each side of the equation once we've isolated that radical. So this radical cancels out with the exponent, and I'm left with x minus 5 equals x plus 1 cubed. Now everything in parentheses is being cubed, so that means that it's x plus 1 times x plus 1 times x plus 1. So we do have to distribute all 3 of these factors. You can only multiply 2 factors at a time, so I'm going to start off with these first 2. So I'm going to distribute these x's and the 1's. So x minus 5 is going to equal to, I'm going to keep it in parentheses to remind myself that I need to distribute it with the x plus 1 after. X times x is x squared. X times 1 is plus x. Another 1 times x is another x. And 1 times 1 is 1. I'm going to combine these like terms here before I distribute once more. So x minus 5 is going to equal to x squared plus 2x plus 1 times x plus 1. Now let's distribute one more time. And remember, I have to distribute everything. So x minus 5 is equal to x to the third plus x squared plus 2x squared plus 2x plus x plus 1. Now let's clean this up a little bit by combining those like terms on the right. So x minus 5 is equal to x to the third plus 3x squared plus 3x plus 1. Now we see here that this is a cubic function because my highest exponent is to the third. Now we can actually factor this just like we factor a quadratic. However, we have to still make the equation equal to 0 before I can factor. And that goes with any type of equation. You always need to make it equal to 0 before you start factoring. So I'm going to subtract the x and add the 5 over to this side of the equation. So here's the minus x, which I will subtract here. And I'm going to add the 5, which I have to add to this one here. So now there's nothing left on this side. And on the right side, I have x to the third plus 3x squared plus 2x plus 6 is equal to 0. When you have a cubic equation like this and you have 4 terms, the method of factoring here is to factor by grouping, meaning you gather the first 2 terms and the second 2 terms. And now you're going to factor out the greatest common factor from each of these groups. With x cubed plus 3x squared, both of these terms have an x squared in common. And when I take out the x squared from these terms, I'm left with x plus 3. From the 2x plus 6, both of these terms can be divisible by 2, more so by positive 2. So I'm going to take out a plus 2. And when I take out the 2, I'm left with x plus, and 6 divided by 2 is 3. You'll know that you factored by grouping correctly if what's inside of your parentheses is identical. So now for our factors. Essentially what we're doing is that this is one term and this is another. And both of these have an x plus 3 in common. So what is the same here, that's one of your factors, the x plus 3. And then what's left over, this is your other factor. So we got the x squared plus 2. Once we've factored, we have to set each individual factor equal to 0. For this one, I'd have to subtract the 3, so x is equal to negative 3. Here, I would have to subtract the 2, so x squared equals negative 2, and then square root. But when I square root here, I get x equals the square root of negative 2, which this is an imaginary number. I cannot get the square root of a negative since there are no 2 identical numbers that multiply to give you a negative 2. So I only have one solution, which is the x equals negative 3. And that's solving square root and cube root equations.